what's up? I'm Liz, this is Split City DIY, and this is a DIY camera slider. It was designed by the Ruiz brothers for Adafruit. You may have seen it when it came out. Now, previously, it was powered by an Arduino with a motor shield on it. But they kind of wanted to redo it and have it powered by CircuitPython. And they asked me to write the code, to which I said, hells yes, sign me up. How do I? Yes, let's go, let's do it, let's type the words, the syntax, functions. I will admit, it was a little intimidating. I'd never written code for someone else's project, which was kind of an interesting experience, just to, like, this already exists, and now I have to, like, write code to make it do what they want to do. It was cool, and it worked out, clearly. It did the thing. It slid, you just saw it. It's proof. It's real. But how does this thing all work? I mean, obviously, as I said, it's powered by CircuitPython, but what's going on? The electronics. Well, for the brain of the operation, we've got a Feather M4, and it requires two Feather wings, or add-on boards if you're unfamiliar, to kind of make everything tick. We've got, of course, a motor wing, which is powering the single stepper motor, and then secondary to that is the mini TFT joystick Feather wing, which is how we are kind of building a control interface for this thing, a physical control interface. Because that mini TFT wing, it has a TFT screen, of course, 180 by 60 pixels, and then it has this little joystick and some buttons. So when you power this thing up, you're presented with some options on the screen for different intervals of sliding. We've got a 5-minute slide, a 10-minute slide, 20-minute slide, and a 60-minute slide, and you can use the joystick to navigate to select which one you want to do. And when you want to start a slide, you just hit select with the joystick, you punch in, and then it starts sliding. It's very nice, it's very majestic. And then during your slide, up on the screen, it says there is a slide in progress, and there is some text at the bottom that updates throughout the course of your slide, letting you know how much time is left. So if you're doing a 5-minute slide, like every 15 seconds it'll say, oh, there's 4 minutes 45 seconds left. There's 4 minutes 30 seconds left, just to give you an idea of what's going on. Now when your slide finishes, once we get from point A to point B, you're presented with two options on the screen. There's a nice split graphic that correspond with the two buttons on the side. You can either reverse the time lapse, which means you just start it up all over again with the same time level, or if you hit main menu, it goes back to home. It just slides on back, everyone's happy, and then you're presented back with your main menu, and you can like start a new slide or switch it off if you're done. It's up to you. In theory, you could keep reversing time lapses for forever. Like, you could just keep going on and on and on again. You know, maybe one slide isn't enough to contain your time lapse ambitions. One additional item that I've added on to this slider, which makes it just have a little bit more versatility, is this motorized turntable. And I bring this up only because it is kind of a budget option for other things that are out there, and I think my fellow, like, video makers will find this to be interesting. It's by Newer, and they make other, like, kind of cheap video peripherals. And so basically you have this, like, little IR remote that has pretty good range, and you just switch it on, and then you can select like 15-minute, 30-minute, or 60-minute for the turning, and then you can select your degrees, 90 degree, 180 degree, 360 degree, and you can do some math to get some pretty cool, like, intervals that can match up with your slide and such. And then you can also go like clockwise or counterclockwise, and it's all on the remote, which is pretty cool. I've had really good luck with it. It's really quiet, which is nice. Sometimes like budget stuff like that, it'll be like loud. But yeah, it's pretty good. It holds the GoPro and my actual camera too. So I recommend it if you are looking for something like that. I'll throw a link down in the description. It won't be an affiliate link because I don't do that. But yeah, just something to bring up, because going across here with your time lapse, that does add motion, which makes a time lapse more interesting than if you just set the camera and let it go. If you add this in too, then you get this really cool, and I'll throw some example time lapses I've done of like my cats and Legos and other fun things, where you can see like you get that extra motion in there. It looks cool. It looks cool. That's really all this project is about. It's like making your shots look cool. It's a cool tool. Now, as I said, my contribution to this project was the code, and only the code, nothing but the code, the whole code. And so I think it'd be kind of a cool opportunity to kind of discuss the code more in like how it's working, kind of in like a conceptual way, and how I kind of approached writing it, because as I said, this was the first time I was really writing code in this way, where it wasn't for a project that I had like come up with. Instead of going like line by line, which can get kind of technical, and also this code's pretty long, so that would be a really long video. In the Learn Guide, I do go line by line and explain what all the libraries are doing and the syntax and everything. So if you're looking to like adapt the code for your own project, definitely check out the Learn Guide there, and it'll kind of give you some more insight into that. But otherwise, let's switch gears a bit and just kind of talk about the workflow and how this whole thing is running from a software perspective. All right, so the code. First of all, whenever you're starting a new project, I find it to be really helpful to think of like the most basic things you're trying to do. For example, this project, our main goal is that we need to move the camera. So we're going to take our camera, we're going to move it. And the next thing we want to do to add like a little bit more is we want to be able to control it with buttons. So once we move our camera, we need to be able to control the different ways that it can move that we program in. The next level up is that we have these buttons that we're controlling our camera with, but we want to be able to know what's happening. What did we just select with our buttons? So we want graphics. And time. Time is really important in this. We want to know how long the slide is that we're selecting, and also like how much time is left, like what's going on exactly. Speaking of time, math is really important with this project, because we need to figure out how to move the camera a specific distance in a specific amount of time. And so we're using the stepper motor, right? And stepper motors are very precise. And they use steps that like slowly go along, and you can dial in the speeds and everything. For just a little bit more accuracy, we're using micro steps. And micro steps on this motor, at least, there are 8 micro steps for each regular step. So it just gives us like a little bit more finesse, right? Basically, we need to figure out how many steps it takes to go the distance of the rail, just in general. And so to do that, I actually wrote this quick script where I just would press a button and the motor would step 1,000 microsteps, and I just kept hitting that button until I got to the end of the rail. So then I knew going forward, okay, the rail is basically this many steps long, using steps as like a measure of distance. And what I got, 17,200 micro steps. It's the length of the rail. So with that, then we can talk about time, right? The camera needs to travel 17,200 microsteps in 5 minutes, in 10 minutes, in 20 minutes, in an hour. And so its speed will affect that. We're going to use 5 minutes for simplicity here, because that's also the smallest. And so the way that we're going to do this is we're going to take our total steps, which is 17,200. We're going to divide it by the number of seconds. And for 5 minutes, that's 300 seconds. And what we get as a result is 57.33 repeating. It goes on forever. But basically what this means is that the stepper is going to need to step 57.33 microsteps per second to stay on time, to keep our camera slide on schedule. And so to achieve this in the code, we're going to need to figure out from a time perspective how often the stepper needs to step to be able to do this. We're going to get this fraction of a second. And the way that we do this is we take 1 and we divide it by our 57.33, and that equals 0.01744. So that means that every 0.01744 seconds, which is upsettingly small, one microstep needs to happen. I know that we said we wouldn't go by line, but basically when we're in the for loop, and I'll throw that up on screen just so you can see, which is how in CircuitPython we would control the stepper motor using the motor library. You have this for loop, there has to be a delay, and in the delay, that's where we throw this in. So it's going to be a time.sleep 0.01744, and that's how it stays on track. And there's a different number for each time interval that we are trying to do with the slider. Just to go back, we've now answered how we're going to move our camera. It's really the most important part of the code. So next important thing is control. So we do have the joystick mini TFT Featherwing, which gives us a lot of control options, which is good. But to do this successfully, we have to use state logic. It means your code's keeping track for you whether or not a button has been pressed. And this can mean a variety of different things depending on how you structure your code. It's like your program is a lifeguard constantly watching vigilantly on what all your different options are doing. And they're fairly easy to set up, and the logic happens in the background so it doesn't affect other things you're trying to run. Like if you've ever tried to do like really quick Arduino code and set in a delay, you know, then everything in your script stops. It's not just that one thing that you're trying to delay. Everything stops. So with states, like you can kind of almost, I almost think of them as kind of workarounds, so that like your code knows what's up and you can kind of dance around these limitations and get kind of fancy with it. And you can also, not just with physical inputs, you can also do kind of software inputs as well, so that when something happens in your code, you can change the state of a variable and you can just like throw in a letter. For example, in the code I actually have a variable called z, which tells us basically where the camera is on one end or the other. And so when it finishes a slide, if a bunch of other states are enabled, then z updates, which is then interpreted as to the position of the camera. So you can get really cool with it, and then that can trigger other things. And it also, in this case, provides some fail-safe logic, because if the camera is here on the rail, and we want to start another slide, we want to make sure it's going this way. We don't want it to go this way where it already went. And because that would happen, it would crash. It would be a calamity. It would just be bad. Skull crossbones. It would be awful. It would be really bad. So with state logic, you can also kind of set in these fail-safes to make sure stuff doesn't happen, just like making sure stuff does happen. So that's how we're going to tell like what our buttons are doing. We go on now to the graphics. If we know in the code what our buttons are doing, then we can use that same logic to tell us what the program is doing on a graphical perspective, which basically means like if we press like this button, then we can have this picture show up. But if we press like this button, then we can have a different picture show up. And if the camera is going this way, it's moving, then we can have another picture show up. So that's kind of how the graphics were handled. When they display is based basically on the state logic. So the last part of the graphics, though, was time. We wanted to show time. Now, it can get real tricky if you're trying to update time like constantly, so that's why we're only doing it 20 times per slide. But the way we can do that is using time.monotonic, which is a function that allows you to basically kind of count time whenever you call it. You can like have these check-ins, and then you can assign variables to those check-ins, and then you can either have that like constantly update in a loop, or you can have it stay static and then do some math based on other timers you have in your code, which is what I'm doing. I call it 2 times when a slide is started, once when you actually press the button, and another time when the camera actually starts sliding, when that for loop starts for the motor. So then we get the actual like 0. Otherwise, there is a little discrepancy between when you press the button and when the slide starts. And then I kind of store that number and I subtract it against the duration of the slide. So basically we get kind of this timer countdown going in the loop because some of that is repeating. And if you want to see like more in depth on how that is, the Learn Guide will have the information. We can then take the result of all that code and print it to the screen using some of the display.io library in CircuitPython, and we can have it update. And the way that I have it update is I actually have it checking in to seeing how many steps the motor has taken, since it's counting up in the for loop. So when it reaches those certain step kind of landmarks, it'll update the time. It'll show whatever time in clock format what's going on. So that's how we're going to get our time there. And those are the main chunks of the code. The way that I laid it out here with these like 3 tenets kind of happening is how I approached writing the code. I worked on all the parts separately. But like I said, if you're looking for a little bit more in-depth walk through the code, Learn Guide's going to have that kind of a line by line, letting you know what all the parts are doing and all the libraries and everything like that. And that, my friends, is the updated motorized camera slider. Now, there will be another video about the slider on Adafruit's YouTube channel, and as I said before, the Learn Guide will have everything you'd ever want to know ever about this project. The assembly, it'll have the CAD files, more in-depth walkthrough of the code line by line if that's more your style, you name it, it's there. Also links to the various supplies that are being used to make this project slide along. But if there's still something you just have to know, leave it down in the comments and I will try to answer it for you. But that's going to do it for this video. Thank you for watching. Consider subscribing for more content like this. And until next time, this has been Blitz City DIY. Slide on, you crazy diamond. All the prog rock fans just rolled their eyes and everyone else was confused.